This is number system, which is a topic we'll be looking at. Under number system, we'll be discussing binary system, conversion from base 10 to any other base, also conversion from other base to base 10. Also, we have conversion from of a number in one base to a number in another base. Also, we have conversion of decimal number base to base 10, conversion of fraction of decimal number in base in base 10 to base 2, addition and subtraction of number base, multiplication and division of number base. Of course, by the time we are done, there are other cases of number base we'll be discussing. Now, this is brought to us by Brain Hub Academy by Kenneth. You can get me on YouTube. Of course, on YouTube, just search Brain Hub Academy by Kenneth Michael. Remember to put by Kenneth Michael or any topic. Just search any topic, by Kenneth Michael. Of course, you should be able to get this. Always remember to share with your friend and loved ones. All right, let's begin. Now the topic is number system. First of all, binary system. When we talk about binary system, what are we saying? The binary system, which you can call the base 2, is the counting of numerals based on 2. Counting of numerals based on 2. All right. So when you are counting numbers based on 2, numerals based on 2, then you are operating under binary system. Then apart from that, the next thing is conversion of number base. How do we convert number base? Okay, so this is a process of changing one number base to another. It involves converting number from base 10 to any other base, and from any other base to base 10. Of course, so you can do your conversion from base 10 to any other base, and also from any other base to base 10. So first of all, we want to learn conversion from base 10 to any other base. So if a number is given in base 10, how do you convert it to base 2, base 5, base 7, and all of that? All right, so now this involves successive division of base 10 by the required base. At each top of division, the remainders are recorded, including 0, until the division is completed. That is, the last quotient being 0. That is the last quotient being 0. The selection is the upward collection. The solution is the upward collection of all the remainders from the last to the first. So by the time let me explain with this example. But what it's all about is that you have to divide successfully with the number you are converting to. Then you copy the number upward. That is what that is saying. Example 1, convert 124 in base 10 to a number in base 8. This number is in base 10 already. I want to convert it to base 8. So solution, what you're expected to do is, you write 124, put, like you find your LCM actually, you put, this is 8. So how many times can 8 enter into 124? It can enter 15 times. And if it enter 15 times, the remainder will be 4. Yeah. If you divide 124 for 8 people, they will get 15, and then the remainder is going to be 4. So therefore, you discover that we write the remainder. So instead of writing remainder in words, we'll be using small letter r to debit remainder. So next one, 8. How many times can 8 go into 15? All right. It can enter 1 time, remainder 7. Okay, so how many times can 8 go into 1? It cannot. So it is 0. It cannot go. So it's 0, and then remainder, the 1 that is here. Look at this one. We bring it here. So therefore, To convert 124 in base 10 to base 8, now we got this remainder. So this remainder they are our answer. So what you do is that this arrow means you are copying the answer upward from this one down to 4. You are starting from this upward. So therefore, thus 124 in base 10 is equals to 174. 174. So that is what it means. Okay, 174, 174. All right, so example 2. Example 2, we see express 437 in base 10. Express 437 in base 10, and then in base 5. Express it in base 5. It's in base 10 already, in base 5. Express this in base 5. Okay, this number is in base 10 to base 5. So the same method follows. You have 5437 is in base 10, then this is converting to base 5. You are going to use 5 all through. So 5 can go into this. How many times? 87 times. When you use your calculator, you can press it and see 87 times remainder 2. 5 into 87. 5 into 87 is 5 into 87 is 17 remainder 2. 5 again in 17 is 3 remainder 2. 3 divided by 5 cannot, so this is 0. Remainder the 3, this 3 will bring the remainder down. So we copy the answer upward. So it's going to be, the answer is going to be 3222. So thus 437 in base 10 is equivalent to 3222, which is in base 5. Okay, so this is how to convert from base 10 to any other base. They can ask you to convert to base 2, from base 10 to base 2, base 3, base 4, base 5, base 6, base 7, base 8, base 9, thereabout. So this is the method to do it. Now the next one is conversion from other base to base 10. Now if they are given to you another base apart from base 10, how do you convert it to base 10? The process is simple. Let's look at it. The process of converting from other base to base 10 involves a successive multiplication. There are basically two methods which we'll be looking at. Okay, I know many people always discuss one method. A lot of teachers use only one method, but I'll be showing you the second method here today, which is quite easy. Of course, the first example one, convert 110101 in base 2 to base 10. If you are converting this value in base 2 to base 10, we go with the method 1. The method 1, we call it power expansion. Okay, it entails multiplying out the number base using their place values. Okay, using their place values. So what it means is that write this number you are converting to base 10, then use each of the number to multiply by its base. The base is 2. So by the time you are done with that, you started, putting the power on the base of the number. Now let me explain further. Look at, let's go now. This first one is 1. So we have 1. That 1 times 2, that is what we have here, 1 times 2. Forget about the power. I'll tell you why the power is 5 later. So 1 times 2, you see, 1 times 2, that is what we have here, then plus. The next value is 1. So that is going to be still 1 times 2, so plus 1 times 2, then plus. The next value is 0. See 0 here, so it's going to be plus 0 times 2 because the base is 2. The next value is 1, so it's going to be 1 times 2. The next value is 0, which is plus 0 times 2. The next value is 1, which is lastly 1 times 2. Now let's look at why the power is like this. No, so by the time you are done, you now go to the power, to the base. The base is 2. The base we have is 2. So anywhere you see the base, you start from 0. Start from 0 from your right hand side. So the first 2 here from my right hand side, is going to be 0. The next one 1. The next one is 2. The next one is 3. The next one is 4. The next one is 5. If you has like that, you continue to put the power in the increasing order. So now we want to expand. So we bring the 1 down, times 2 raised to power 5 is 32. Then plus this plus down. Then 1, this 1 is done. Then times, the times is done, times 2 raised to power 4 is 16 plus 0 down, times 2 raised to power 3 is 8, then plus this 1, we bring it down, then times 2 raised to power 2 is 4, plus this 0 is what we bring here, times 2 raised to power 1 is 2, plus this 1 is what we brought here, then 2 raised to power 0 is 1. Always remember, note, 2 raised to power 0, anything raised to power 0 is 1. Anything raised to power 0 is 1. Okay, so we multiply. 1 times 32 is 32. Look at it here. 1 times 16 give us this 16. 0 times 8 is 0. Anything multiplied by 0 is 0. Anything multiplied by 0 is 0. Take note. But anything raised to power 0 is 1. Take note. Okay. All right. Then plus 1 times 4 is 4, plus 0 times 2 is 0. Look at it. Plus 1 times 1 is 1. So we add them together now. 32 plus 16 plus 0 plus 4 plus 0 plus 1. If you have your calculator, when you press it, it will give you 53 in base 10. So this is one of the method. We call it power expansion method. Okay, which a lot of teachers actually use. Then the second method, which is easy and fast. Example, maybe you are taking a CBT exam. This method is faster. Okay, this method is successive multiplication. This one is a successive multiplication. Now, look at this example. Change 625 in base 7 to base 10. It's in base 7, so we are changing to base 10. Now, if you want to, you can use the first method to solve this, but this is the second method. Now, let's use the second method to see how we can solve this. Now, this second method is a successive multiplication method. How is this successive multiplication? You take the first digit or the first value, multiply it by the base. Look at it, 7, the base multiplied by the first digit, 7 times 6 plus. By the time you say plus, it's going to be plus the next digit of the number, which is 2. Look at it. Plus the next digit of the number. What it gives to you, what this mathematical setup gives to you is going to be 44. 7 times 6, then plus 2. 7 times 6 plus 2 is 44. So that is the first method. The base multiplied by the first digit, then plus the next digit. The answer it gives you, write it. Then go to the next line, which is the next step, equals to. Use the base again, which is 7. Remember, you have treated 6, you have treated 2, so the next value to treat in this value now is 5. So therefore, it's going to be 7 times 5, and 7 times 45, and 44 rather, sorry about that, 7 times 44. Okay, then the next value you want to treat is this 5. So 7 times this 44 we have gotten, then plus the next digit which we are yet to treat is 5, then plus that 5. That is why we have 5 here. So 7 times 44, then plus 5 will give you 313 in base 10. Now, your first assignment is you can pause this video and try to use the first method. Use the first method, okay? Use this first method to see if you can, get the same answer. All right. Remember, my WhatsApp line is always there. You can always chat me up, or on Telegram. On Telegram, you search Brain Hub Academies by Kenneth Michael. You'll see the channel there. You can join the channel and get the note. This note is already on the channel. Thank you. Then the next example, convert 134 in base 5. This is base 5. This is 5, okay, to base 10. Okay, then let's use the first method to solve this. Of course, this is expansion method. You have to expand. 1 times 5 plus 3 times 5 The next one is 4 plus 4 times 5. Then we start putting the power from the right hand side of the base, which is 0. The next one is 5. The next one is 2. Now, the common mistake here is that sometimes student tends to put the power on the digits. No, or either 4, 3, or 1. No, is the power is only on the base of the number. The base is 5, so that is where we put the power. So this is 1 down times down, then 5 raised to power 2 is 25 plus 3 down times 5 raised to power 1 is 5 plus 4 times 5 raised to power 0 is what? Is 1. Remember that anything raised to power 0 is 1. Then this is equals to this. 1 times 25 is 25 plus 3 times 5 is 15 plus 4 times 1 is 4. So 25 plus 15 plus 4 is 44 in base 4. Now let's use the second method. 1, of course, 1 times 5, the base here, 5 times 1 plus the next digit is 3 plus 3 is going to give us 8. Then the next step is going to be the base again times 8. This 8 you got, 5 times 8, then plus the last digit is 4, all right, which is going to give us 44 in base 10. So even if you have the next digit, you continue like that. This is how to convert from other base to base 10.